Hey, and this week's video is going to be back to the basics, and we're going to be talking about factorization, which is a very simple tool, I say, but it is very important, and if you don't get it, then a lot of the stuff that comes after that is more complex is not accessible to you simply because you don't know how to factorize. So I would like to touch upon three main types of factorization, and all of these are going to be quadratic factorizations. So first of all, we'll start off with the simplest form, and that's where you have an xa plus xb. And this would have you taking out the x and having it as a plus b. So let's take a look to contextualize this. So let's say I have a 7x plus a bx. I can rewrite this as x times 7 plus b. It makes sense, right? I'm taking out the common factor. I am factorizing. Factorizing is taking the common factor out. Remember that. This can also be done if, for example, you have a common factor that's not only x, but it can be 3x. So for example, if you have 3x plus 12a, you can factorize this to be 3 times x plus 4a, right? Because if I take out the 3, I'm left with x, and I'm left with 4a, because 12 divided by 3 is 4. And let's do a second example where let's say we have 5y plus 10x plus 25a. We can factorize this to be 5, because that's the common factor, y plus 2x plus 5a, right? If we take 5 out, we basically divide everything by 5. If we divide this by 5, we just get y. If we divide this by 5, we just get 2x. And if we divide the last term by 5, we get 5a, right? Okay, let's move on to a little bit of a more complex factorization. And this one is the one that you sometimes end up using the quadratic root formula for. Okay, and first let me write a couple of rules for this. So basically, what you're going to end up with when you factorize this is a form where you have bracket x plus, what do I know, k times x plus j, okay? And the rule is that x with a k plus j is going to equal to b, and k times j is going to equal to c. And while this might throw you off at first, let me show why this makes total sense. So for example, let's quickly actually contextualize this problem. And let's say that we have an x squared plus 3x minus 28 is equals to 0. So how would you factorize this? Well, we know that we have to have k plus j be equal to b, and k times j is equal to c. So we have to find two numbers that will add to give us 3 and will multiply to give us negative 28. And you might be thinking, wait, but 3 times 1 is 3, and what other factors are there? Or like 3 is a pretty small number, but we're adding together. Well, you must remember that you have a negative. You have negative 28. So let's start off by looking at the factors of negative 28. So you can have 28 divided by 2. That's going to be 14. And 14 minus 2 is not going to give you 3, right? Let me show you this a bit more detail. So you have 28. 28 is negative 2 times 14. That doesn't really fit us. 28 divided by 4, on the other hand, is negative 4 times 7. And what is negative 4 plus 7? Well, that's just going to equals to 3. So we have found our two numbers that work. And then we can just rewrite this as x minus 4 times x plus 7 is equals to this, is equals to 0 in this case. And you can go back and expand the brackets and see what you get. So you have x times x, which is going to give you x squared. You have x times 7, which is going to give you 7x. Then you have negative 4 times x, which is going to give you negative 4x. And you have negative 4 times 7, which is going to give you negative 28. And this is where the justification kind of comes into play. Look at what we are doing. If you have this general form, and you can see this, go back and look at this in the example that we just did. You have x plus k times x plus j. You're going to have, first you're going to go like this, right? And you're going to have x squared. Then you're going to go like this, and you're going to have plus jx. Then you're going to multiply the k times the x. So you're going to have kx, and then you're going to multiply this, and you're going to have kj. And what is this? This is exactly the rule that we have over here, because this can be simplified to x squared plus, and here we can factorize the x out, j plus k. This is an x, by the way, sorry, that does not look like an x, plus kj. And this is exactly the rules here. We say that b must equals to k plus j. That's exactly what we have over here. We have that c must equals to kj, and that's exactly what we have over here. So I hope that makes sense. All right, and now let's move on to our final form of factorizing quadratics. And this one is a bit more complex, but it still has a very similar form to the last one. Here we're going to have ax squared plus bx plus c is equals to 0. And here, as you can see, what the difference is that there's a coefficient in front of the x as well. So it's not simply here, our coefficient was 1, which made things quite simple for us, as you will be able to see right now. So let's go through the strategy. This one is a bit more complex, and there are different ways people do this, but I'm just going to show you how I do it. So in my preferred method is to multiply a times c, and then you have factors of this number, right? And the factors of this, one of the factors, are going to involve a combination. Let's go back to our numbers of k and j. And this will be such that k plus j is going to equal to b, once again, and k times j is going to equal to ac, but we already have this acquainted for. The only thing that we start by doing is by multiplying these two coefficients. So let's put this into actual practice. So let's say we have 2x squared plus 7x plus 5. So what's 5 times 2? So 5 times 2 is just going to equal to 10. So you have to find values that will multiply to give 10 but add to give 7. So that's pretty easy, 5 and 2, right? We literally just looked at this. So we're going to break this up into 5 and 2. We're going to say 2x squared plus 2x plus 5x plus 5. And here we're just breaking this b into more parts so that it's easier for us to then obviously factorize it. So here, let's take the 2x out. So we're going to have 2x plus x plus 1 plus 5x plus 1. And it's very important that you have these brackets that are the same, because what does this remind you of? This reminds you of expanding brackets. So you can just reverse operate and have x plus 5 times x plus 1. In this case, would equal 0. Sorry, I didn't write that. But that makes sense, right? So this is our, and if you go back to factorize it, you'll get this. So let's do a second example. 6x squared plus 37x plus 6. Let's just factorize this. So we know that 6 times 6 is equals to 36. And now we have to find two factors that multiply to give 36, but that add to give 37. And in this case, it's quite simple. It's just 36 times 1, right? 36 times 1 gives you 36, and then 36 plus 1 it gives you 37. So you can rewrite this, or we can rewrite this, as 6x squared plus 36x plus x plus 6. And now let's factorize this. So let's take 6x out, and we have x plus 6. And then in this case, we just have plus 1, because x plus 6 doesn't need any other factor. It's already x plus 6. So we're going to end up simplifying to 6x plus 1 times x plus 6. Makes sense, right? So let me write this in step form, just in case, so it's easier for you to understand. So we have ax squared plus bx plus c. Our first step is to find k and j such that kj is equals to ac, and then k plus j is equals to b. So this is exactly what we were doing over here. This is our k, this is our j. They add to give b, they multiply to give ac. And this is just taking a step forward where it was only times c, because here it only had to be times c because this was 1, so c times 1 is just c, right? But here we have something else. And then you split your equation, you split your terms of b, so your terms of b should be split into kx times jx, which is still going to be the same thing as bx. And then you factorize. And that's it. It's pretty simple. All right, so I hope you don't forget these very important skills, and always start off with a simple way of factorizing, then move on into a little bit more complex, and then you can have a go at this. And it's all very logical. If you just work there and look at it for a second and think how this factorization actually works, you'll totally get why we take the steps that we do. All right, so I hope you enjoyed this video, and see you. Bye-bye.